Hello, good morning, everyone. Hope the student for Science 2 and for Science 3, now you are in the live YouTube. Okay, so today I just want to continue the 4.2. That means I want to complete it about the specific heat capacity. So hopefully you can refer the notes and also we discuss together about the last part for this one 4.2. Okay, good morning, everyone. You can see me and also listen me or not. Okay, good morning, Xiliang. Okay, the rest, are you here or not? Can you give me some response? Hello, anybody here? You can type in the chat room. Just say hi here that I know you are in the live now. Okay, Maxine. Okay, so today I want to continue lah. Chen Ru also here. Okay, Dan Yuxuan. Okay, good morning. Okay, so we can start now. Okay, we still 4.2. The topic still the same. Okay, there is a specific heat capacity. Okay, now it's a series 2. So I continue to what I want to show. Okay, first one, go and see the, okay, morning, Noreen. Okay, today I want to continue about the specific capacity. So hopefully you still remember this one specific heat capacity is what's the meaning. Okay, if I say high specific heat capacity means they're not easy to heat up. They will take some time to heat up. They also not easy to be cooled down. They also need some time to be cooled down. That one is a high specific heat capacity. Okay, if I say low specific heat capacity means they are easy to be heat up. That means they absorb a little bit heat, then they rise the temperature. Okay, you also can say they're easy to be cooled down. Okay, maybe you give 5 minutes, they already cool down, release the heat faster. That one we call it as a low specific heat capacity. Okay, so from here we're going to see the water. So today we just want to mention about the water and also it's an aluminium block. That means we just want to mention about the liquid and solid specific heat capacity. Okay, first one, water has a high specific heat capacity. So the meaning is what? The water is not easy to be heat up. Okay, you want to heat up the water, you need to make it a longer time and also you need to make it in a high temperature. Okay, number two, they will absorb large amount of the heat to have a small rise in temperature. So although you provide so many heat, okay, but the water only increase a little bit temperature. Okay, water is a good cooling agent. Okay, why there's a good cooling agent? Because they can absorb more heat, is it? So you want to cool down something, we're using the water to cool down. Okay, water can absorb more of the heat from the heater object. So that means after some time, all the heat will release from the object, go where? Go to the water. Water come out is a hot water. So water is one of the good cooling agent. Okay, how about the metal? Metal has a low specific heat capacity. So that means metal will be easy to heat up compared to the non-metal. Okay, so from here, therefore, the object made from the metal, they will get hot quickly. Okay, when they supply with an amount of the heat. So something you want to faster to heat up. So we build the material normally is a metal lah. Okay, normally the thing you do want to heat up faster. So that means you still can hold it by using your bare hand. That means we create by using non-metal. Okay, so this one is normally we're talking about the thing you want faster to heat up or you want to slow down. So we just think about the specific heat capacity. Every material specific heat capacity should be different. So how to application depend for your situations. Okay, now later we got see some of the application about the specific capacity in our daily life. Okay, so let's see the first one. This one is from your textbook that just show you the table about the specific capacity. So we compare liquid and metal. So let's see the liquid. You can see the water. Water is a high specific, around 4,200. Oil is a 1,890. So that means oil should be faster to be heat up lah because you want to cook, is it? So from here, compared to the metal, Metal good conductor should be lead. Good conductor means easy to be heat up. So that should be the lead. 130 only. Aluminium will take some time. Although all is a metal, different metal also got different specific heat capacity. Okay, next part. Next part should be the gas. Okay, gas we find it the A. Okay, the normal A is about 1000. Okay, the methane should be 2200. Okay, different gases also got different specific heat capacity. Okay, non-metal. Okay, glass we take 670. Okay, the polycarbonate will take 1250. So that means the glass is more easy to be heat up compared to the sand, compared to the concrete, compared to the wood. Okay, so this one is a different material, got different specific heat capacity. When you find the number bigger, means what? The object will take longer time to heat up. Okay, if you find the number is smaller for specific heat capacity, means the object easy to heat up. Okay, now we go through the one of the experiment from your textbook. This one experiment, they want to find what is the specific heat capacity of the water. Just now we from the table, we get it. There's a 4,200, is it? So we want to prove. Is it we do the experiment, we can get the answer or not? Okay, let's see apparatus. Okay, from the apparatus, we need to using is a immersion heater. Okay, we need the heater because you want to heat up something. Okay, after that, we're using the beaker, stopwatch, okay, thermometer, retort stand, water, tissue paper, and electronic balance. Okay, let's see the diagram. Okay, so this one is a diagram how to set up. Okay, beaker inside got water. Okay, after that, you're using the tissue paper to wrap the beaker. So this one later, they will ask you why you need to wrap like this. Okay, then after that, we got power supply. Power supply join with the heater. Later, you want to heat the water. Then after that, we got thermometer. Okay, this one, the electronic balance. Later, we want to measure about the mass lah. Okay, how many mass already disappear. Okay, how many mass already evaporate. So from here, the immersion heat, the electronic balance, they want to measure the mass of the water. Okay, let's see the procedure. First step, they say wrap the beaker with the tissue paper. Number two, you need to place the beaker on the top of the electronic balance. So you put on the top of the electronic balance means you want to find out what's the mass. Okay, reset the reading to 0. Okay, fill the beaker with the water until there's a 3/4 full. Record again the reading of the mass of the water from the electronic balance. So that means before that there's an empty beaker. When you fill in the water, then you measure again the mass. So that means we just want the mass of the water. We don't want the beaker. So later you need to minus. Okay, record the initial temperature. Before start, measure what is the temperature of the room temperature of water. We label by data 1. Okay, now remember switch on. Switch on the immersion heater and start the stopwatch. Okay, simultaneously. So when you just switch on, then you start your stop. Okay, now you need to observe the chain in the thermometer readings. Sure, they will increase lah because you got heat, is it? So we need to wait until after 5 minutes. Okay, after 5 minutes, you switch off the immersion heater. Record the highest thermometer reading. So this one we call it as a final water temperature. We label by data 2. Okay, so from here we want to see the table. After finishing this one experiment, we need to fill in the result. Okay, I got one of the example result. You can refer here. Okay, power heater. So before that, you need to know the power immersion heater. What is the power? So they got label. They got label at the power immersion heater there. So you just copy what is the watt. So there's a 36 watt example. Okay, heating time. Just now they say 5 minutes, is it? But for the experiment, we normally using SI unit. We didn't using the minute. So you help to convert. 5 minute change becomes second. So they become 300 seconds. Okay, the mass of the water. So mass of the water, just now we measure already. So that's 0.42 kilograms. Okay, initial reading. Initial reading is before you go to heat. They get it, there's a 27 degrees Celsius. After heat, They get it 33 degrees Celsius. So this one is an example result we get it. Okay, now what we need to do, we need to find out specific heat capacity for the water. Okay, normally the student, you know the formula. The formula is a this one formula. Normally we're using this formula. C equal Q over M changes temperature, is it? But now we didn't using Q. Okay, now the Q is provided from where? From the heater. So if the question just say got heater or they say power supply, we need to change Q equal PT. P stand for power. T stand for time taken. So just like your formula for power, power is a energy over time, is it? So that means Q is a energy. That's a heat energy. So I want to find the heat energy. So should be P multiplied T, PT. So now the new formula I want to introduce when the question they're using power supply. Okay, using the heater. So we need to change about the Q become PT. So now specific heat capacity for the water, we're using this formula. C equal PT over M changes temperature. So from here, you need to count by yourself what is the changes temperature. Okay. So from here, I let the student to answer me what is the answer for the specific heat capacity for the water by using this formula. So you prepare your calculator, apply all the info from the table. By using this formula, you give me the answer for C. Okay, I want the answer C. Okay, so the student, you can ready to give me the answer. Okay, Chen Lu already give me the answer. Is it correct or not? Okay, 1,800. I think a little bit difference on this answer. Okay, P multiply T, 36 multiply 300. Not 5 minutes. Remember? Don't do the mistake. Okay, anybody here? Okay, wait, the student give me the answer for the specific heat capacity for the water. Okay, anybody can type. Oh, Lim Liang give me the answer. Okay, so we're going to check. 4,285.71. Okay, what's the unit? Okay, we check the unit. Okay, unit is long a bit for the specific heat capacity. That's you need to take about the joule per kilogram per degree Celsius. Okay, we go to put in. Okay, so 36. Okay, 36 watt, 300 watt, 300 second. Then 0.42 is a mass. Then changes temperature is 33 minus 27. So from here I get it. Okay, 4,286. If I round number, become 86 joule per kilogram per degree Celsius. Okay, can you see a little bit changes with the actual? Just now through the table, we find the water is what? 4,200, is it? So when we do the experiment, we cannot get the perfect. Okay, we get 4,200 about something. So normally we get the answer is more than the actual. Okay, yeah. Okay, Tan Chen Lu, there's a 0.42 multiply the 6. Okay, remember, when we do the experiment, we get the result always more than actual. Later, they got one of the question to ask you why. Why we cannot get 1,800? 1,800 already lower, is it? Lower, that means you got problem. So normally we do experiment, we get higher reading. Okay, later we go to explain why we get higher. If you get higher, it's okay. That's a correct. Don't be higher over lah. Around a little bit 4,500, 4,300 also can. There's a around close to the actual, but you are higher a little bit. Okay, now we see why we get the answer like this. Okay, so from here we got discussion. Why does the beaker then need to be wrapped with the tissue paper? Why we need to wrap it? Okay, the reason is we want to prevent the heat loss. Okay, although you using the beaker is not the metal, but the heat there still be loss to the surrounding. So normally we wrap with tissue paper is want to reduce the heat loss to the surrounding. Okay, number two, why the water temperature data too? They're not taken as soon as the 5-minute heating times end. Straightforward, 5 minutes, then you take. No, we need to make it off the switch. Then you go to make it until the no increasing already, then we read. Why we cannot exactly go to read? Okay, the reason is to make sure that the A and the heat achieve thermal equilibrium. So that means you make sure the mercury already is a maximum height already. They never drop. Okay, then you go to take. Never drop, never increase, then we go to take. Okay, that one is want to make sure the A surrounding got A and also the heater that achieve thermal equilibrium. So that means both sides is the same temperature. Then we go to read the readings. So that one is what reading we need lah after 5 minute maximum readings. Okay, number three. Given the specific heat capacity is how many? 4,200. Compare the value specific heat capacity of the water obtained from the experiment. Okay, just now you obtained how many? 4,285, is it? So explain why there's a difference. Okay, now you see, be careful. Why got difference? Okay, first, the value of the specific heat capacity we find it is greater than actual. Okay. Number two, heat loss. Although I using the tissue paper go to wrap, they still got heat loss, is it? So from here, the heat you lost to the surrounding. When the heat lost to the surrounding, you tell me the temperature, the final temperature cannot increase higher because you lost, ma. Actual maybe achieve until 40, but you lost already, so you achieve 33 degrees Celsius. So that means we say changes of the temperature decreases. Okay, for the actual, when they do the experiment, maybe they can increase more because they prevent the heat loss already. When they just prevent the heat loss, that means the changes temperature become higher. When we just do the experiment in the lab, maybe they will lose because we just open A, is it? Maybe you're on the fan, you're on the window, they will lose the heat. So that means the changes temperature decreases. When the changes temperature decreases, what happened? Okay, we go and see. This one is what we find just now. Now I show the formula again. Formula just now we're using is a C equal Q over M theta. Okay, Q we take PT, is it? Okay, this one is a reason. Xiliang, how they prevent the heat loss. Okay, they just do in the small area. Maybe they're using the polystyrene cover whole experiment and do inside. Okay, then we cannot open just like the open area and do it. Then the fan must be off. Then they prevent the heat loss lah. Normally it's a cover one. Cover part, they don't have more air inside. Okay, they just cover. After that, they do it in a polystyrene box, black area. This one is one of the thing to prevent the heat loss. Okay, they're using the black box. After they put all the thing in, after that they go and do it. Okay, this one is one of the thing that can prevent. But maybe they got more of the equipment they need to using to prevent the heat loss. Okay, so from we do it, we sure got lost about more of the heat. So from here, they say the formula C equal Q over M data. So if the data decrease, okay, the question again, can we use a plastic cup to prevent the heat loss? But plastic cup, you want to prevent the heat to heat up also because some plastic cup, they cannot absorb more temperature. Okay, you want to prevent the plastic cup also melt. This one is one of the thing. Okay, normally plastic and the glass will more better lah is with the high temperature. Okay, so we want to prevent the melting also. Plastic, we can use plastic, but just scared about the temperature too high, the plastic they got infection. Okay, so this one also can. Important, we want to take something can be conduct electricity. Okay, do not absorb the heat. That one is okay. Okay, so that's why they're using the tissue paper to wrap it. Sometimes they just put above the polystyrene, don't put on the table. Maybe the table also absorb the heat. So this one is how to prevent. Okay, so from here, the last one is C equal Q over M data. If the data decreases, data is a changes temperature. Just now we say already, when we do experiment, the changes temperature very, very low. Okay, when they do the scientists, when they do the experiment, the changes temperature is very, very high. Maybe 27, they can go until 50. Okay, after 5 minutes. So that means the changes temperature, 50 minus 27, there's a big number. Compare, we do experiment 44 minus 27, or you just get 33, 33 minus 27, just a small number. So when you get the data is a small number, understood, C will be increases because data and C is inversely proportional. Okay, so this is one of the reasons why we cannot get the actual. If you get closer already, like this, do the experiment, 4,200, you are 4286, means you already is closer. Closer means what? You lost energy become less. Okay, almost close to the actual value. Okay, if you get 5,000, means you are more of the heat already lost to the surroundings. Okay, just now is a water specific heat capacity. Now it's a 4.2. Okay, 4.2 about the solid. Okay, the solid we using aluminium. Okay, specific capacity for the aluminium. The apparatus should be the same, but now they mentioned for you aluminium using solid, is it? So solid no need using the electronic balance. We straightforward to measure aluminium block is how many mass. That's a 1 kilograms. Okay, we're still using the heater, stopwatch, thermometer, retostat, and tissue paper also. Okay, now we're going to see the procedure. Okay, so you can see the diagram. They're using the tissue paper to wrap the aluminium block. So above the surface of the aluminium block, they got two of the hole. Okay, two hole. Okay, one hole should be put the thermometer. They want to put in the thermometer. Another hole, they want to put the heater. Okay, so from here, the setup almost the same lah. So before that, we need to jot down what is the temperature before you start. So all the thing you put in, so you go and see the thermometer, then move until what reading. Then you jot down that one is the initial temperature. Then you start to switch on the immersion heater. Okay, when you just start to stop the immersion heater, you start, simultaneously the stopwatch also start. Okay, so after 5 minutes, also is a 5 minute, switch off the immersion heater. Immersion heater, you go to switch off. Okay, again, record the highest temperature reading of the final temperature of the aluminum block. There's a data 2. So that means you need to drop down data 1 and also data 2. Okay, let's see the table. Power supply, okay, this one power supply, maybe they're using another power supply lah, because they want to heat the heater, heat the aluminum block, the chain using the 50 watt. Okay, time taken is the same, we take 300 seconds. Okay, mass of the aluminum just now is 1 kilograms. Okay, initial, we still 27. Okay, after 5 minutes, we find the aluminum block, that increasing the temperature become 42 degrees Celsius. Okay, so again, we need to find what is the specific heat capacity for the aluminum block. Okay, the formula is the same. Q equal PT, C equal Q over M changes temperature. Now the Q, you help me to change become PT. Okay, now the formula is the same. C equal PT over M changes temperature. Okay, so you need to tell me what's the answer for the C. Okay, for the C of the aluminium block. Okay, of the aluminium block, what is the specific heat capacity? Okay, anybody here? Can straightforward to press your calculator to get the answer. Okay, Chen Lu, remember, don't mistake. Okay, changes temperature into minus 42 minus 27. Okay, anybody here can give me the answer for C? 1000. Okay, Praveen, Krisha, morning. 1000, is it? Okay, we got to check, huh? Siliang also 1000. Ahmad also 1000. Okay, okay. Must have unit, lah, Ahmad. Okay, unit from Chelu also 1000. Okay, Siliang give me the full unit. Okay, now we go to show, huh? 50 multiply 300. Okay, then over 1 kilograms. 42 minus 27. Okay, so we exactly get it. 1000. Okay, 1000. Okay, we need to compare with the actual. Okay, so normally we get the answer is a higher reading. Okay, now we go to discussion. What can be done to obtain better thermal contact? Okay, thermal contact between the bulb of the thermometer and the aluminium bulb. Okay, we put in the hole, is it, for the thermometer. How to make it better thermal contact means the faster to transfer the heat to the thermometer. Okay, so from here, remember we need to add one thing in the hole. Okay, for the thermometer hole, not the heater. Okay, we need to add some droplets of the oil. Okay, some droplets of the oil in the thermometer hole of the aluminum block. Okay, what's the reason? If they ask why you add some oil, we want to increase the thermal contact between the thermometer and also aluminum block. Okay, the oil can be helped to increase the thermal contact. Okay, so that's why the thermometer can get the heat faster. Okay, get the heat faster, so the bulb, they got mercury, is it? So the mercury will be expand faster. Number 2, give the specific heat capacity aluminium 900. Okay, aluminium block is 900. We find is how many? We find 1000, is it? So we compare the value. Value sure is a higher. Okay, give the reason. The reason also same. Okay, the value of the specific heat capacity is greater than the actual. Okay, so heat will lost to the surrounding, chain of temperature decreases. So we get it is 1000. Actual is a 900. Because of the formula, we go to refer. Okay, excuse me. Can use other liquid. Normally, we never using alcohol. Alcohol also is a good good thermal contact, but the alcohol will evaporate faster. So normally we using the oil is a better. Okay, oil, any oil lah, depends for yours lah. Okay, any cooking oil, any oil, we also can use it as a good thermal contact. Okay, so water we cannot use. Water should be the high specific heat capacity. So we're using the oil is one thing can make it become smooth. Okay, reduce the frictions when the thermometer put inside the hole. Okay, number 2 is one to make the thermal contact lah, thermal become better. Okay, so the last one is a formula. Okay, C and also the changes temperature. When you find the changes temperature decreases, so the C automatic, they will increase. So the concept should be the same. I don't care about the aluminium or you're using the water. Normally, we find out the specific heat capacity is higher than the actual. So this one question, they normally will ask you why we get the value higher than the actual. So you need to answer lah, because the heat lost to the surrounding changes temperature with decreases. Then you need to show about the formula. C and changes temperature, what is the relationship? Okay, the relationship is inversely proportional. Okay, so this one is a 2 of the experiment. They want to find out what is the specific heat capacity for the water and aluminium. Okay, so from here we need to see some application for the specific heat capacity where we use it. Okay, first one they normally use as a cooking utensil. Okay, you can see example the metal wok. Okay, the body of the wok. They are made with the metal with the low specific heat capacity. Means they're easy to heat up. Easy to heat up means as such the food can be fried at the high temperature in a short time. Okay, if you take it as a high specific capacity means the wok cannot be heat up. So if it cannot be heat up, how your food can be cooked faster? Okay, unless the situation you want the food stay longer to hot. Okay, stay longer for hot means we're using the clay pot lah. Okay, the clay pot is made from the clay, which has a high specific heat capacity. So the food can be stay hot for long time. Depend the situation what you want to use. Okay, so the material also changes. If you want the in what function is a different. You want faster, so the material must be low specific heat capacity. So that means you want the food to cook slowly, keep hot, then you need to using the material should be high specific heat capacity. So normally this question come up from the AC. They ask you what material you want to use. Better don't answer the name of the material. Don't say I want aluminium lah, I want clay lah. Don't mention because we do know the material for the certain metal. We just mention high specific heat capacity, or you just mention low specific heat capacity. Don't mention the name, because arrangement just now, the aluminium and the lead, we also do know actual reading, is it? So from here, don't mention the name, just say you want high or low. That's all. Okay. So from here, number two. Number two is a car radiator system. So radiator system, they want to cool down the engine. So from here, first one, the burning of the fuel in the car engine, they produce low amount of the heat. So this one heat, they need to be released to avoid overheating the engine. So from here, water is the most suitable liquid because first one cheap lah, everybody know, easy to get it, and also the cost should be low cost. Okay, another one is a high specific heat capacity. Okay, you can using the cooling liquid, up to you. That one is a chemical things, but you need to buy lah. Okay, but the water is a one of the thing temporarily you can solve the problem when they're just overheating. So water has a high specific heat capacity and used as a cooling agent. Okay, they can cool down. Okay, a pump with the pump water into the engine block. Okay, water will flow through the engine block. So this one you call engine block. The water will flow through. Every block they go to flow through. So when they just flow through, they will absorb the heat. Because just now told you, water is a high specific heat capacity. So that means they can absorb more of the heat. But the temperature, they keep slowly to increase. So that means the water can go through every part that absorb the heat. Okay, after that, the hot water absorb all the heat already. Now the water become hot lah. Hot water will flow to the radiator. Cool air is sucked in. Okay, you can see the cool air can be sucked in by the fan. The fan rotate, then the cool air to suck in. So after that, the heat in the hot water can be released quickly through the cooling fan. Okay, so that means the system should be the water go to cool down all the pump first, all the engine part first. After that, the water become hot already. Then they through the fan. The fan will suck in all the air in. Then they go to cool down the water. Then the water flow out. So that means now the whole system become cool already. So if you're just using the air flow, they cannot go to the part of the block. Okay, this one is an engine block. They cannot go part to part. So the water can be flow. So the water can flow part to absorb the heat. Okay, Silan got question. High specific heat capacity not cool down faster. No. How the clapboard can be stay hot for a long time? Because they keep more heat. Because they heat up slowly. When they just heat up slowly, that means they absorb more heat. When they just absorb more heat, they're not easy to be release the heat. So high specific capacity means slowly to heat up and slowly to cool down. Slowly to cool down. So that means the clay pot, they keep, although you never heat already, but inside they already got heat. They will keep the food become warm for longer time because they already is a high temperature. So from here you say high specific capacity, not cool down faster. Yeah, correct. So that's why the clay pot can be stay hot for longer time. They do not cool down faster. They cool down long time. So that means you want the clay pot easy to cool down, very hard. You need to take some time. The food you want to keep inside the clay pot, okay, they will stay for longer time hot. But important, you need to heat for longer time also because they want to absorb more heat. Okay, after you off the fire, so the clay pot will keep warm for longer time. Okay, they also cool down slow. Okay, so remember, don't mistake. Heat up slow, cool down also slow. Okay, heat up faster, cool down also faster. Okay, high specific means what? Not easy to heat up, and also not easy to cool down. Okay, understand or not, Siliang? Okay, so this one is one of the radiator. We're using the water as a cooling agent. Okay, this one is one of the outer layer of the space capsules. Outer layer, they're talking about the surface. Okay, this one is a space capsules. On its journey, they back to the Earth encounter air resistance when entering the atmosphere. So from here, this one friction, because they want to go through the air resistance. Friction will increase the temperature. So after that, they will cause the space capsule to be burnt because too high temperature. So therefore, when it just burn the outer layer space, when it just create, must make from the very high specific heat capacity and also high melting point. That means they're not easy to be melt. Okay, reason why they want to build like this, your answer should be do not heat up easily. If they say high specific heat capacity. Okay, number two, do not melt easily in the high temperature. They do not easily to be melt, although the temperature is high. Okay, so high specific capacity, that means they make longer time, then they can be heat up. Okay, in short time, they never heat up easily. Okay, then we go to the one of the application, they call it as a diamond building. So they're using the material to build the roof, okay, roof of the buildings. So from here, you can see the diamond building energy. The commission is built with an insulating. Okay, again, the question from Liang. So why use water as a cooling agent? Water is a high specific capacity, means they can absorb more heat. Okay, they can absorb more heat. So they absorb the heat from the engine. After that, they release. Yeah, slow. Slow lah. So that means the engine, when it just run, the water need to moving slow lah, but they absorb more heat lah. Slow is okay what? They do not very fast what? They can absorb more heat. Okay, if you more water, that means faster lah. So that means the heat can be slow to absorb. Okay, but they will absorb more to come out. Okay, if you're using the oil fast, but what to do? The oil already heat up, so the engine not yet cool down. This one, is it? So important is the water already heat up, then the engine cool down. That's a good what we need to choose water. Okay, the oil faster to heat up, but the engine still hot with no use. Okay, slow is okay. The engine release the heat is okay. Slowly is okay, but important they can release. Okay, so this one is why we choose the water. Okay, diamond building energy commission built an insulating concrete roof. That's a roof filled with the insulator using the trough form board. Okay, at the top is a trough form board. Let's see what's the reason. Trough form board has a high specific heat capacity. Means at the top, the board is a high specific heat capacity that can reduce the absorption of the heat. So at the top, there's a very high specific capacity, means that not absorb the heat faster from the surrounding, okay, to reduce the temperature inside the building. Okay, one day, that means they do not absorb too much, maybe less lah. If you say many days also got sun, that one will become, the whole building become hot. Okay, so if one day is okay one, okay, one day they got sunshine, is it? So the surface, the roof surface, there's a high heat specific capacity, so they do not absorb the heat easily, so the whole building do not increase the temperature. So this one is one of the diamond building they built by using the trough form board. Okay, this one is another application for specific heat capacity. They're using the building material as a wood. Okay, in a warm weather, Okay, warm weather region. Okay, traditional house is built by the wood, which function as an insulator of the heat from the sun. Okay, insulator heat, the wood should be the insulator, like they do not easily absorb the heat. Sorry. Okay, reason why we choose the wood. Wood has a high specific heat capacity and get hot slowly. So this one is a reason why we choose the wood to build the house. Okay, so from here you need to answer lah, because wood is a high specific capacity, do not absorb the heat easily. Okay, then during the cool also the same. Okay, during the cool, the weather region, traditional house also built from the wood. Okay, another explanation. Okay, during the cool, they also built by the wood. But from here, you cannot say there's a high specific capacity. Okay, because they release the heat slowly. From the cool, we don't have any sun already, so they cannot absorb the heat. But the heat now from where? Inside the house. So the heat from the fire lit in the wooden houses cannot flow up. So this one we cannot say outside already. Okay, we're talking about inside. Okay, inside means heat from the fire lit in the wooden houses, they cannot flow up. But because the wood is a function as a good heat insulator. Okay, they do not release the heat to outside. They keep the heat inside the house. Okay, so this one is a material they're using the wood build the houses during the hot weather and also the cool weather. This one is a function for the wood. Okay. Okay, this one is a one of the thing I think everybody also know lah. Then also the essay every time to come out, they ask you about the applications. So the first one we're talking about the body of the pot, body of the pot made by aluminium, which has a low specific heat capacity. So from here, if you don't know aluminium or copper is good, don't mention. You just say I use low specific heat capacity material. Reason, enable the pot to heat up quickly. Okay. Number two is a handle. Normally the handle don't want cook fast, don't want heat up faster, is it? So from here, the handle must make from the plastic. Okay, if you don't mention the plastic, you just mention high specific heat capacity material. Okay, so we not just plastic, others also can, is it? So from here you just say high specific heat capacity. So the reason, enable the handle of the pot get hot slowly and also safe to handle. Okay, and the last one should be the base. The base will be hot faster, is it? So the base is made out of the copper, which has the low specific heat capacity. Then the reason, enable the base of the pot heat up very quickly. So the base normally is heat up first compared to the body. Okay, so if you don't mention about the material name, is okay. You just mention you want high or low specific heat capacity. So not just for this one situation, when you just mention high specific heat capacity, your reason sure do not heat up faster. If you say low specific heat capacity means heat up faster. So this one is a one pair. Okay, one pair reason and also characteristic. Okay, so this one I'm going to introduce about the air from the sea move towards the land. Okay, this one you need to explain by process question, means 4 marks. You need to explain one by one. Okay, point by point. Means you can refer the diagram, then after that answer. Don't memorize one sentence by one sentence. Okay, we just remember the keyword. After that, you create your sentence by refer the diagram. So you see the first step. Okay, you see the diagram. The first step is from the land. Okay, we go to answer during, the first step is from the sun. Okay, first we need to mention during the day. Okay, during the day, land heat up faster than the sea water. Okay, we got sea, we got land. Land will hot first, get hot first. Okay, number two, we're talking about the land. Okay, why? Because the land has low specific heat capacity than the sea. Okay, Land will heat up first because there's a low specific heat capacity. Okay, number 3, we see about the hot air. When you heat up, you create the air above the land is a hot. So number three, when the air above the land is heat up, so the hot air will be rises up. Okay, the hot air will be rises up to upwards and also create that area become low pressure because the air not enough already. Okay, air already rises up, that means the area become low pressure. Okay, after that we go number 4. Number 4, we're talking about the cool air. Okay, number 4. Now the cool air is a high pressure because you create one part become low pressure, another side should be higher pressure compared to the land, is it? So the cool air now above the surface of the sea, they will move towards to the land. Okay, so this one we call it as a sea breeze. Only 4 mark you need to explain. So the question just give you one sentence. Please explain the sea breeze by using specific heat capacity. That's all. Then you need to answer point by point, 4 point, at least for 4 point lah. So I not encourage you memorize point by point. I encourage you to memorize through diagram. Okay, from the diagram, you just write the keyword, then you create the sentence. So that means we no need to see my full sentence one. You no need follow me exactly. Important, you got keyword. So the first step you say during the day, land heat up faster compared to the sea. Okay, number 2, why? Because the land got low specific heat capacity. Number 3, the air above the land rises up. Okay, rises up. Okay, after that create low pressure region. Okay, number 4, the air above the sea is high pressure. Then they will move towards to the land. So this one we call it as a sea breeze. Okay, sea breeze means the air come from the sea to the land. We call sea breeze. And this one just happened during the day. Okay, then we go to opposite. There's a night day. Okay, during the night. Okay, during the night, now you can see the diagram again. Number 1 also start from the moon. Okay, this one called land breeze, means the air from the land move to the sea. This one is happen during the night. At the night, also same, heat is lost from the land and also the water. Both also lost the heat, but which one lost the sure is the land because land is a low specific heat capacity, is it? So they lost the heat faster lah, compared to the sea. So number 2, the sea has a higher specific heat capacity. So from here we're talking about sea already. Sea higher specific heat capacity than the land. So the temperature in the sea drops slowly compared to the land. Okay, so you can talking about land low specific capacity, you can talking about sea also can. So if I'm talking about the sea, sea is a high specific capacity, means not easy release the heat. So the temperature still high lah, compared to the land. Okay, number 3. Number 3 is talking about the air above the sea rises up. Okay, number 3 should be here, hot air. So the hot air above the sea rises up because the sea heat up, they're not yet cooled down. So the air above the sea still rises up. So when it just rises up, they create low pressure. Now above the sea already is a low pressure. So what happened for the land? So now the air above the land is higher pressure compared to the air above the sea. So the cool air, high pressure above the land, they will move towards to the sea. Okay, so this one we call it as a land breeze. Okay, you want to explain about the sea also can. You want to explain about the land also can. Okay, depend for the situations. Okay, you want the both also land also can. If I using land means land has low specific heat capacity, so the temperature of the land drop faster. Okay, then after that you're talking about the hot air. Must talking about the hot air. The hot air above the sea rises up. Then after that they create low pressure. So the pressure, A pressure above the land is higher, then they will move from the land to the sea. So this one we call it as a land breeze. Okay, so I think my time just got 5 minutes, is it? So I want the student stand by the calculator to answer me. Okay, we got one example question. Okay, 0.5 kg metal block. Okay, that's a heated by the 50 watts of power. For 90 seconds, the temperature of the block rises from the 20 to 45. 20 to 45. Calculate the specific heat capacity for the metal. Okay, so I show the info first. Okay, this one is the info. Mass 0.5 kg, power, time taken, changes temperature 25. So you need to find specific heat capacity. So I show you the formula. Okay, so now you can give me the answer for question number 1. Okay, you just apply the P, apply the time taken, then over the mass and also changes temperature. Then you give me the answer for C. Remember, must have unit. Okay, for the specific heat capacity of this metal. Okay, we're going to check any student can answer here. Okay, hurry. We just got 5 minutes. I think got 5 minutes only lah. So the student can faster to answer. Just type your calculator, then straightforward give me the answer. Okay, anybody? Okay, again, Xiliang. Only always a Xiliang lah. Okay, we get the answer. Okay, Amir also got. Okay, go and check the answer. Okay, we apply. Okay, we apply 50, 90. Multiply. Then after that, divide 0.5, then bracket 25. So we get the answer 360. Okay, unit. Unit is joule per kilogram per degree Celsius. Okay, don't forget the unit. Okay, so this one is the first question. I think there's a no problem. Okay, we try to the second question. Okay, second question. 20 gram of the boiling water at 100 degrees Celsius, they pour into the glass containing 200 gram of water. Okay, both also water. So what we can cancel? Specific heat capacity we can cancel. Okay, now 2 water mixed together. Okay, you need to calculate final temperature. The final temperature both must be the same lah because they achieve thermal equilibrium. So we just write the info. Okay, M1 is the boiling water, 20 gram, 100 degrees Celsius. Okay, mass 2. Mass 2 is the normal water. Normal water is a 200 gram, then 28 degrees Celsius. So from here, actually both also is a gram. We just ignore. No need to change, become kilograms. So what I need to show, I show the formula. Q1 equal Q2 because finally the heat must be the same. Both transfer heat is equal. Okay, no net heat flow. So from here, MC data 1 equal MC data 2. So data 1 means what? Data 1 minus data. Data 1 means it's 100 degrees Celsius minus final. Sure your final is less than 100. Another one, sure your final more than 28. Agree, because your final temperature must around 100 to 28 between, but we don't know how many. Okay, so from here I need to apply the formula. Okay, M1 is how many? 200. Okay, we take M1 is a 200. Okay, then my bracket final temperature minus 28. Okay, equal. M2 is what? M2 we take this one is this part, the 20 gram. 20 gram of the boiling water. Boiling water temperature should 100 minus final temperature. So I want to find is a final temperature. Okay, just let you to help me to find the final temperature is how many. Okay. So the student, please answer The other also must be answered, don't only Celia or one person only. Okay? The thing we can just put in. Okay, the 200, I can make the 20 to here. When the 20 move another side, I go to divide. So I just left about 10. So depend for yours lah. This one is a mathematic calculation already. Okay, anybody can find the data F? Final temperature 34.54. Okay, 34.54. Okay, the others. The others you get or not? 34.54. Okay, we go to check. Okay, finally I get 11 data F equal 380. So the final is, yeah, correct. 34.54, 34.55. Okay, degree Celsius. Okay, so from here, this formula we're just using when they're just mixed together. Okay, remember, when they mix together, you need to find out is it both liquid is the same or not. If same, that means the specific capacity we can cancel. If not same, that means you need to put in. Okay, so when number 3 become number 4. Okay, help me to do the number 4. Okay, 2 kilowatt, 240 volt electric heater is used to raise the temperature of 3 kilogram water. If the power supply, 8 minutes. So what is the increase in the temperature of the water? They want to find data. So they give you the specific heat capacity. So we write the info. Okay, mass 3 kg, power 2000, 2 kilowatt, you need to change become watt. Then the time taken, that's a 8 minute, 8 multiply 60 become 480. So specific heat capacity is provided. Then they ask you, what is the changes temperature? So from here, we need to show a formula again. PT equal MC data. Okay, now the question, they want to find the T. Okay, they don't want to find the C. C already get it. So that means now we just put in all the info. Okay, they want to find data, sorry, find data. So 2000 power, multiply the time taken, 480. 3 is a mass. Specific heat capacity provided, then we need to find data. Okay, so you give me the answer for data is how many? Okay, again, they want to find the temperature. Okay, anybody? Just a simple question. Important you understand. You need to write the info. That one is important. Okay, if you never write info, that means you find the question is so many info, but we don't know which one and which one. When you just list out, that means you're more easier to be understand the question. Okay, 76.19. So from here we continue. Okay, put in all the things. So I'm going to find the data. Data 76.19 degrees Celsius. Okay, correct. Then we continue to number 5. Okay, number 5. Okay, you see this one question a little bit. Okay, Chen Lu also correct. 76.19. Okay, number 5. 1.2 kilowatt immersion heater is used to raise 0.2 kg water in the copper container. This one got a little bit info because the water now in the copper container, we got two things already. Copper container is 0.05 kg. Okay, then 0.2 kg is the water. Okay, now both is together. Then you're using the heater go to heat up. Now you need to calculate the time taken so that the temperature of the water and container increase by 20. Now the question already give you changes temperature for the water and copper is the same. There's a 20. Okay, now the question give you two specific heat capacity, one for water, one for copper. So that means later both also need to use it. Okay, now we're going to check the info. Okay, mass water 2, mass copper 0.05 kg, power 1200. Then the specific capacity for water 4200. Then for the copper 400. Time taken, don't know. Okay, so we're still using PT lah because they want to find the time, is it? So but now PT equal MC data. Now the problem is we got two MC data. one is a water, one is a container. Then they also together. So we just write the info, PT equal MC data. Now the situation is PT equal MC data of water plus MC data of copper. Because both is a different specific heat capacity, you cannot mix together one. Okay, so we need to separate and plus together. Okay, so from here, PT we know 1.2, T we do know. Okay, 1.2 kilo, there's a 1,200. T we do know. Okay, then this one is for the water, 2 kilogram. Specific heat capacity for the water, 4,200. Then the increased temperature, 20. Okay, the copper container, 0.05. Then the specific only 400. Then the changes temperature also 20. So final, I want to find the time taken. Okay, so this one should be the last one. Okay, so your answer time taken to heat up these two material together and increase 20 degrees Celsius. So that means the time taken you're using is how many? Okay, both also 20 because the water and container that achieve thermal equilibrium. So two also get the final temperature is 20. Changes is 20. Okay, Chenru give me 140.33, the time taken. Okay, unit. Okay, unit, they must have second. Okay, so from here, 140.33 second. Okay, correct. So you want to change to minute, is up to you lah. Normally, we just get it in second, then enough already. Don't waste the time to change, unless the question call you to change lah. Okay, so from here, then finish. So what you need to do today must be complete the 4.2. Okay, copy the question and write the answer in your exercise book. Okay, so you also need to do is a Google form. I already upload there for today attendance. Okay, key in the Google form. After that, write the code. Okay, today lesson code. Okay, listen carefully. Celia, help me to type. Number 217. 217 hashtag 8. Okay, 217 hashtag 8. Okay, this one is a today lesson code. Then you answer the question. Around got 10 questions. Okay, about the specific heat capacity. Okay, if you never answer, that means I assume you never attend my class. Okay, so from here, Silang can type or not? 217 hashtag 8. Yeah. Okay, no spacing. No spacing. You straightforward type 217 hashtag 8. Okay, you type inside the Google form. Don't copy and paste. You type by yourself. Don't spacing. Okay, don't enter also. Okay, so that one is today lesson. Yeah, correct, Dylan. Okay, so our lesson just until here. So thank you for your watching. So you can continue to do the exercise. Okay, everyone. Just say bye to you all. Okay, to be continued for the next lesson. Okay, bye.